Welcome back to Statistics Made Simple, and in this video I'll be finding solutions to problems based on linear programming problems. So in this video I am solving some problems on the linear programming problem, which is a very important and sure question. That is, the 35th question is a LPP problem, which is a 5-mark problem. So do practice all the various types and do listen to the explanation which I have given. So if you practice these kind, you'll be able to solve any problem on LPP. And remember that you should solve the LPP problem only on a graph sheet and not in the answer booklet. 35th question, solve the following linear programming problem graphically. Minimize z equal to 10x plus 8y subject to constraints 4x plus y greater than or equal to 40, 2x plus 3y greater than or equal to 60, and x comma y is greater than or equal to 0. So 35th question is a fixed question. It's an important one which is always based on a linear programming problem. So now let's start with the first step. So the first step is to convert inequalities to equalities. So write step 1. Convert inequalities to equalities. So it will be 4x plus y is equal to 40 and 2x plus 3y is equal to 60. Now step 2 is we have to draw these two lines. So to draw a line you need a minimum of 2 points. So step 2 is to obtain the points of the two lines. So you start with the first equation. So write consider 4x plus y is equal to 40. So first you put x equal to 0. So you'll get y is equal to 40. Second you put y equal to 0. So you'll get 4x is equal to 40, which implies x is equal to 40 divided by 4, which is equal to 10. So therefore 0, 40 and 10, 0 are the 2 points of the first line. Then similarly you take the second equation. So you consider 2x plus 3y is equal to 60. Now you put x equal to 0. So you'll get 3y is equal to 60, which implies y is equal to 60 divided by 3, which is equal to 20. And next you put y equal to 0. So you'll get 2x is equal to 60, which implies x is equal to 60 divided by 2, which is equal to 30. So therefore 0, 20 and 30, 0 are the 2 points. So now step 3 is to draw the graph. So I have already drawn the graph. To draw the graph. So that is drawn over here. So now let me explain how to draw the graph. So now you have to mark the points 0, 40, 10, 0 for the first line and 0, 20 and 30, 0 for the second line. So on the x-axis you can take 0, 10, 20, 30, 40, and similarly on the y-axis you can take 0, 10, 20, 30 and 40. So mark the first point 0, 40, that is here, and then you mark 10, 0, which is here. Mark these 2 points and on that line you write 4x plus y equal to 40. Next you mark 0, 20, that is here, and then you mark 30, 0, that is here. Join these 2 points and on that line you write 2x plus 3y is equal to 60. Next, write the scale. X-axis 1 centimeter is 10 units and y-axis 1 centimeter is equal to 10 units. Now the next step is to obtain the feasible region. So step 4, to obtain the feasible region. So now to obtain the feasible region, we should consider the inequalities which were given. So consider 4x plus y is greater than or equal to 40. In this you put both x equal to 0 and y equal to 0. So on the left hand side you will get 0. On the right hand side you have 40. You have to check whether 0 is greater than 40. It is not greater. So we get the condition as false. So similarly, take the next inequality. Consider 2x plus 3y greater than or equal to 60. Again, put x equal to 0 and y equal to 0. So you'll get 0 on the left hand side and you have 60 on the right hand side. 0 is not greater than 60, so you write false. So now we have to do the shading part in the graph. So for both the equations, we got the condition as false. So whenever you get false, you have to shade away from the origin. That means on top of the line. So you take the first equation, that is 4x plus y equal to 40, and then you shade on top of this line. Okay, so I've used the zigzag lines. So away from the origin, that is, I've used black color zigzag lines, and then you take the other equation 2x plus 3y equal to 60. Even that the condition is false, so you have to shade away from the origin on top of the line. So I've used blue color. Now what you should do, you have to see where both the types of shading are there. So if you take this particular area, there is no shading at all. If you take this triangle, only the zigzag lines are there. If you take this triangle, you have only the blue lines, but only this open area, it has the zigzag line as well, it has the slanting blue lines. So for a minimization problem, you should always get, you need not get a closed figure. It can be an open figure or a closed figure. Here we have got an open figure. Even then you will have a solution. So now we have to find out where both the types of shading meet, and then you have to mark these as the corner points. So the corner points are A, B and C. So A is 0, 40 and C is 30, 0. Now you have to find out B correctly. So B, if you see here on the x-axis, this point will be 6, and on the y-axis this point over here is 16. So B is 6, 16. So next you write step 5. So step 5, you should write the corner points. So the corner points are A is 0, 40. Then you have B, that is 6, 16, and C 30, 0. So now the last step is to evaluate the objective function at the different corner points. So you can write step 6 as evaluate Z at the corner points. So take the objective function. So consider minimize Z equal to 10x plus 8y. So next you find out ZA. So ZA will be 10 into 0 plus 8 into 40. This will be equal to 320. Similarly, find out ZB. So ZB is 10 into 6 plus 8 into 16. This is 60 plus 128 is equal to 188. And then ZC, that is 10 into 30 plus 8 into 0 is equal to 300. Now, because the objective function is a minimization problem, you have to find out the least z value. The least z value is 188. So next, write the last step, which is the conclusion. So conclusion is the given LPP has an optimal solution at, you should write the point B 6, 16, and the minimum value of z is equal to 188. So note that a minimization LPP can have an open figure, or it can also have a closed figure to have a solution. Thirty-fifth question, solve the following linear programming problem graphically. Maximize z equal to 2x plus 3y subject to the constraints x plus y greater than or equal to 350, 2x plus y less than or equal to 600, and x comma y is greater than or equal to 0. So step 1 is we convert inequalities to equalities. So it will be x plus y is equal to 350, and you will have 2x plus y is equal to 600. Step 2, to obtain the points of the two lines. So now you start with the first line. So consider x plus y is equal to 350. So first put x equal to 0. So you'll get y is equal to 350. And then you put y equal to 0. So you'll get x equal to 350. So 0 comma 350 and 350 comma 0 are the points of the first line. Now similarly, you take the second equation. So you consider 2x plus y is equal to 600. Then you put x equal to 0. So you'll get y equal to 600. And when you put y equal to 0, you get 2x is equal to 600. So which implies that x is equal to 600 divided by 2, that is equal to 300. So the 2 points for this line are 0 comma 600 and 300 comma 0. So now the next step is to draw the graph. So step 3 is to draw the graph. So I have already drawn the graph on the graph sheet, and remember that in the exam an LPP problem should be drawn only on the graph sheet. And the 35th question is a sure question on LPP. So do practice it well so that you can score the full 5 marks. So now on the x-axis, I have taken the scale as 1 centimeter is equal to 50 units, and on the y-axis also I have taken 1 centimeter is equal to 50 units. So on the x-axis I have marked from 0 to 350, and on the y-axis I have marked from 0 to 600. So 350 is the largest x value and 600 is the largest y value. So let us draw the first line. So to draw the first line, we mark 0, 350. So this is 0, and so x is 0 and y is 350. So mark 0, 350 here. And the other point is 350, 0, that is x is 350 and y is 0, so that is this point over here. Then join 0, 350 and 350, 0 by a straight line, and on that line you write x plus y is equal to 350. Now move on to the next line. The 2 points are 0, 600. So x is 0 and y is 600. So here mark 0, 600. And the other point is 300, 0. So at this point x is 300 and y is 0. So mark this point as 300, 0. Then join 0, 600 and 300, 0 with a straight line, and on that line write the equation 2x plus y is equal to 600. And also don't forget to write the scale. X-axis 1 centimeter is 50 units and y-axis 1 centimeter is equal to 50 units. So now we move on to step 4. So step 4 is to obtain the feasible region. So to obtain the feasible region, what we do is we consider the inequalities which were given. So you take the first inequality, that is consider x plus y greater than or equal to 350. Now here you put both x equal to 0 and y equal to 0. So we get a 0 on the left hand side, and you have to check now whether 0 is greater than 350. So 0 is not greater than 350, so it is false. Similarly, you take the other inequality. So the other inequality is 2x plus y less than or equal to 600. So here again you put x equal to 0 and y equal to 0. So we get 0. And now 0, you have to check whether it is less than 600. So 0 is less than 600. So it is true. So now going back to the line x plus y equal to 350, that is this line over here. Because we have got false, how should you shade? You have to shade away from the origin, that means on top of the line. So for this line, that is x plus y equal to 350, because the condition which we have got is false, you shade on top of the line, that is away from the origin, which I have used black color. And for the next line, that is 2x plus y equal to 600, we have got the condition as true. So you have to shade towards the origin, that is below the line, and I have used red color. Okay, so now you have to check where you have both the types of shading. So remember that for a maximization problem, you should always get a closed figure. So closed figure can have 3 sides or it can have 4 sides. So in this case, this triangle here, it has the black color shading as well as the red line. And it is a closed figure. So mark this closed figure by the alphabets A, B and C. So now we move on to step 5. So what is step 5? So step 5 is to write the corner points of the feasible region. So if you observe carefully, the corner points of the feasible region are A. A is 0, 600. Next we have to find out B. So B, if you observe carefully, it is 0, 350. And then we have to find out C. So C, it is not possible to write it immediately. So what you have to do is where the two lines intersect, it is C. Now here at this point, you have to drop a perpendicular to the x-axis. That will be the x value, that is 250, and from this point C you draw a line parallel to the x-axis such that it touches the y-axis, and this point, if you observe, it is 100. So C is 250, 100. Next we move on to step 6. So step 6 is to evaluate Z at the corner point. So now let us evaluate Z. So what is Z? It is 2x plus 3y. So now let us find out ZA. So ZA will be 2 into 0 plus 3 into 600. This is 1800. And ZB, it is 2 into 0 plus 3 into 350, which gives us 1050 on simplification. And ZC is equal to, it is 2 into 250 plus 3 into 100. So we get the answer as 800. Now, because this is a maximization problem, among the Z values, we should find out which is the maximum or the largest value. So the maximum value is 1800. So now let us write the final conclusion, as I don't have space over here and I wanted to finish it in this slide. I have written the conclusion in red color. So therefore the LPP has an optimal solution at, so you should write the point, that is A, 0, 600, and the maximum value of Z is 1800. 35th question. Solve the following linear programming problem graphically. Minimize Z equal to 10x plus 15y subject to the constraints 4x plus 3y greater than or equal to 24, 4x plus 5y less than or equal to 40, and x, y greater than or equal to 0. So remember that an LPP should be solved in the graph. The calculations can be done in the answer booklet. So the first step is to convert inequality to equalities. So the first equation will be 4x plus 3y equal to 24 and 4x plus 5y is equal to 40. Step 2 is we have to obtain the points of the two lines. So we'll consider the first equation 4x plus 3y equal to 24. Put x equal to 0. So you'll get 3y is equal to 24 or y is equal to 24 divided by 3, which is 8. Similarly, put y equal to 0 in this equation. So you'll get 4x is equal to 24 or y is equal to 24 divided by 4, which is 6. So 0, 8 and 6, 0 are the 2 points of this line. Now take the second equation. Consider 4x plus 5y equal to 40. Put x as 0. So you'll get 5y equal to 40 or y is 40 by 5, which is equal to 8. Similarly, put y equal to 0. So you'll get 4x is equal to 40, which implies x is 40 by 4, which is equal to 10. So 0, 8 and 10, 0 are the 2 points. Now the third step is to draw the graph. So to draw the graph, you have to take on the x-axis 1 centimeter as 2 units. So take the x-axis from 0 to 10 and the y-axis also you can take from 0 to 10. Next, to draw the graph, so to draw the line 4x plus 3y equal to 24, first we mark 0, 8 on the y-axis here and then 6, 0. Then these 2 points are joined by a straight line and on this line we write the equation 4x plus 3y equal to 24. Similarly, to draw the next line 4x plus 5y equal to 40, the 2 points are 0, 8 and 10, 0. So 0, 8 we have already marked, so that will be the same point here. And on the x-axis you mark 10, 0. Join these 2 points by a straight line and on that line you write 4x plus 5y equal to 10. So make sure that you mark the x-axis, the y-axis and also write the scale, that is x-axis 1 centimeter is equal to 2 units, y-axis 1 centimeter is equal to 2 units. Now the fourth step is to find the feasible region. I'll be explaining it in the next slide, but this I have solved it on a graph. So step 4 is to obtain the feasible region. The above graph is similar to the graph which I have drawn on the graph sheet, but this I have generated on Excel sheet. So first we take the inequality now, not the equation. You consider 4x plus 3y greater than or equal to 24. In this inequality, put both x and y as 0. So on the left hand side, you will get 0, and on the right hand side you have 24. So 0 is not greater than 24. So it is false. So whenever the condition is false, we shade away from the origin, that is on top of the line. Take the other inequality, 4x plus 5y less than or equal to 40. Again put x as 0, y as 0. So on the left hand side we get 0, and on the right hand side we have 40. So we see that 0 is less than 40, which is true. So when the condition is true, we shade towards the origin, that is below the line. So observe carefully now. So this is the equation. Let me just change the color. So this is the equation, that is 4x plus 3y equal to 24, and this is the other equation. So this is the other equation, that is 4x plus 5y is equal to 40. So now this particular equation, that is the first equation, that is 4x plus 3y greater than or equal to 24. Okay, it is false, so it is shade away from the origin. So this is the line. So you shade away from the origin means we have to shade on the top like this. And the other equation, that is 4x plus 5y less than or equal to 40, it is true, so we have to shade towards the origin, that is this particular line. So we shade downwards towards the origin, and you will see now where the common feasible region is. So the common feasible region is this triangle which I am indicating on the slide. So these are the corner points of the common feasible region. So what do you mean by common feasible region? The common feasible region should contain both the types of shading. So if it's a minimization problem, you can have either an open figure or a closed figure. But here in this particular problem, the minimization problem has a closed figure, and so we have a feasible solution. So step 5, to obtain the corner points of the feasible region. So this particular triangle, the corner points are denoted by A, B and C. So A is 0, 8, B is 6, 0 and C is 10, 0. Now the last step is to evaluate Z at the corner points. So you take the objective function, consider minimize Z equal to 10x plus 15y. Then find out the value of Z at the point A. So you will get 120. Similarly, find out Z at point B, you will get 60, and evaluate Z at point C, you will get 100. As it is a minimization problem, you have to find out the least value of Z, which is 60. So the conclusion is the given LPP has an optimal solution at B, and then specify the point, that is 6, 0 and Z is equal to 60. Fourth question, graphically solve the following LPPs. Subdivision A, maximize Z equal to 3x plus 5y, subject to x plus 2y less than or equal to 200, y less than or equal to 60, and x, y is greater than or equal to 0. So let us start the problem. So the first step is to convert inequalities to equalities. So write step 1, convert inequalities to equalities. So you'll get x plus 2y is equal to 200 and second is y is equal to 60. Step 2, to obtain the points of the lines or the two lines. So take the first equation. Consider x plus 2y is equal to 200. So you put x equal to 0. So you get 2y is equal to 200, which implies y is equal to 200 divided by 2, which is equal to 100. So next you put y equal to 0. So when you put y equal to 0, you will get x is equal to 200. So therefore 0 comma 100 and 200 comma 0 are the points of this line. Now the second equation will be y equal to 60 itself. Now step 3 is to draw the graph. So I have already drawn the graph as shown above. So on the x-axis I have taken the scale as 0, 20, 40, 60 up to 200, and on the y-axis I have taken 20, 40, 60, 80, 100. So the scale is x-axis 1 centimeter is equal to 20 units and y-axis 1 centimeter is equal to 20 units. So now we have to draw the first line, that is x plus 2y equal to 200. So take the first point 0, 100. So this is x equal to 0 and this is 100. So this point will be 0, 100. The other point is 200, 0. So this point here is 200, 0. Now these two points are joined by a straight line, and on that line you should write x plus 2y equal to 200. Now the other line is y equal to 60. So this is the y-axis, 60 is here. So at 60 you should draw a line parallel to the x-axis, and this line you should mark it as y equal to 60. Now step 4, to obtain the feasible region. So now to obtain the feasible region, you have to make use of the inequalities which are given. So you take x plus 2y less than or equal to 200. Now you put x equal to 0 and y equal to 0. So on the left hand side you will get 0 and on the right hand side you have 200. So check whether 0 is less than 200. It is less than 200. So you write true. Next, the next inequality is y is less than or equal to 60. So now because you have only the y term on the left hand side, you put y equal to 0. So you will get 0 and on the left hand side is 0, right hand side is 60. So check now whether 0 is less than 60. It is less than 60. So you write true. So for both these inequalities, we have got the condition as true. So whenever it is true, we have to shade towards the origin. So for this first line, x plus 2y, that is equal to 200, we got the condition as true. So I shade towards the origin, that is below the line. I have used blue color slanting lines. And then for the inequality y less than or equal to 60. Again the condition is true, so this is y equal to 60. So again you have to shade towards the origin. I have used red color lines. Okay, so now the next step is you have to find out where both you have the blue color lines and the red color lines. So the area where we have both the red color lines and blue color lines is this area. See this triangle, it has only blue color, and this like a quadrilateral which has four sides, it has both the slanting lines, that is blue color lines, and it has the red color lines. So remember that for a maximization problem we should get a closed figure. Closed figure means it should have like three sides or it should have like four sides, like this particular diagram. So step 5 is to obtain the corner points. So you should find out what are the corner points of this feasible region. So feasible region means again where you have both the blue color lines and the red color lines. Maximization problem, it has to be a closed figure. So this is the closed figure. This you mark it as A, this you mark it as B, and this you mark it as C. Okay, so I'll just use a different ink so that you will be able to make out what are the points. So this A is actually, we already know it is 0, 60. And this B, it is, if you see this point, you should draw a line here so that it touches the x-axis. This is 80, and from this point you should draw a line over here, that is 60. So this B, the point is 80, 60, and C, you know, it is 200, 0. So these three are the corner points of the feasible region. So let us write down the three corner points. So the three corner points are A, that is 0, 60. Then we have B, that is 80, 60. And then you have C, that is 200, 0. So now the last step is step 6. So you have to evaluate Z at the corner points. So you consider maximize Z equal to 3x plus 5y. So now find out ZA. So ZA will be 3 into 0 plus 5 into 60. So you will get 300. Then ZB is 3 into 80 plus 5 into 60. So it is 240 plus 300, which is equal to 540. And then find out ZC, which is 3 into 200 plus 5 into 0, so which is equal to 600. Now it is a maximization problem, so among these Z values you should see which is the largest. It is 600. So now write the last step. So the conclusion, the LPP has an optimal solution at, you should write the point, that is C 200, 0, and the maximum Z is equal to 600. Subdivision B, maximize Z equal to 20x plus 80y, subject to 2x plus 6y less than or equal to 60, x plus 4y less than or equal to 32, and x, y greater than or equal to 0. So write step 1. Convert inequalities to equalities. So you'll get 2x plus 6y equal to 60 and x plus 4y is equal to 32. Step 2. To obtain the points of the two lines, so consider 2x plus 6y equal to 60. So first put x equal to 0. So you'll get 6y equal to 60. So which implies y is equal to 60 divided by 6, which is equal to 10. Next, put y equal to 0. So you'll get 2x is equal to 60. So which implies x is equal to 60 divided by 2, which is equal to 30. So therefore 0, 10 and 30, 0 are the points. Now take the next equation. So consider x plus 4y is equal to 32. So put x equal to 0. So 4y is equal to 32, which implies y is equal to 32 divided by 4, which is equal to 8. Next, put y equal to 0. So you will get x equal to 32. So therefore 0, 8 and 32, 0 are the 2 points of this line. Then step 3 is to draw the graph. So now look at the graph. So on the x-axis, I have taken the scale as 0, 5, 10, 15, 20, 25, 30, 35. And on the y-axis, I have taken the scale as 0, 2, 4, 6, 8 and 10. So x-axis 1 centimeter is equal to 5 units and y-axis 1 centimeter is equal to 2 units. So we will mark the first point, that is 0, 10. So x is 0 and y is 10, that is over here. So mark 0, 10. The other point is 30, 0. So on the x-axis you take 30 and 0 and mark it. Then join 0, 10 and 30, 0 by a straight line, and on that line you write 2x plus 6y is equal to 60. Then take the next 2 points 0, 8. So this is 0 and this is 8. So mark 0, 8 and then on the y-axis find out 32 and then mark 32, 0. So join 0, 8 and 32, 0 by a straight line, and on that line you write x plus 4y is equal to 32. Next is step 4. So step 4 is to obtain the feasible region. So to obtain the feasible region, we should take the inequalities which were given. So take the first one, that is consider 2x plus 6y less than or equal to 60. Then you put x equal to 0, y equal to 0. So on the left hand side you will get 0. On the right hand side you have 60. So 0 is less than 60, which is true. Then similarly take the next inequality. Consider x plus 4y less than or equal to 32. Again put x equal to 0, y equal to 0. So you'll get 0 is 0 and then on the right hand side you have 32. Check whether 0 is less than 32. It is less than 32, so it is true. So whenever it is true, you have to shade towards the origin. So I take the first line 2x plus 6y equal to 60, because the condition is true, I've used red color and I've shaded towards the origin, that is below the line. Then you take the next line, x plus 4y equal to 32, and again the condition is true. So I've used blue color slanting lines towards the origin. So next is you have to find out the common feasible region. So again this is a maximization problem. For a maximization problem you should get a closed figure, and this is the only shape like a quadrilateral which has four sides and it has both the blue color and the red color. So mark this point as A. So A is, you will have 0, 8, and this point B you should find out, that is where both the lines are intersecting. So from this point B you can drop a perpendicular to the x-axis. You will see that on the x-axis the value will be 24, and on the y-axis you draw a line parallel to the x-axis such that it is touching the y-axis. It will touch at 2. So this point B is 24, 2, and next you find out what is C. So C we already have marked, that is 30, 0. So step 5, you have to write down what are the corner points. So corner points are A, that is 0, 8, then B 24, 2, and C is 30, 0. Then step 6 is to evaluate Z at the corner points. So you consider maximize Z equal to 20x plus 80y. So find out ZA. ZA will be 20 into 0 plus 80 into 8. So it will be 640. Then find out ZB. So ZB will be 20 into 24 plus 80 into 2. So you will get 480 plus 160 is equal to 640. Then find out ZC. ZC is 20 into 30 plus 80 into 0. This will be 600. Now this is a maximization problem, so you should find out the largest Z value. So there are two Z values which are the highest, and it is the same, that is 640. So now we will write the conclusion. The LPP has a multiple optimal solution at, you should write both the points, A 0, 8 and B 24, 2, and the maximum value of Z is equal to 640. Subdivision C, maximize Z equal to 2x plus y such that x minus y is less than or equal to 10, 2x minus y is less than or equal to 10, and x, y are greater than or equal to 0. So do the first step. Step 1. Convert inequalities to equalities. So x minus y is equal to 10. Then 2x minus y is equal to 10. Then step 2. To obtain the points of the two lines. So take the first equation, consider x minus y is equal to 10. So first you put x equal to 0. So you'll get minus y is equal to 10, which implies y is equal to minus 10. Then you put y equal to 0. So you'll get x equal to 10. So the points are 0, comma minus 10 and 10, comma 0. Now take the next equation. Consider 2x minus y is equal to 10. Put x equal to 0. So you'll get minus y is equal to 10, which implies y is equal to minus 10. Next you put y equal to 0. So 2x is equal to 10, which implies x is equal to 10 divided by 2, which is 5. So the 2 points are 0, comma minus 10 and 5, comma 0 are the 2 points of the line. So now on the x-axis, we take the scale as 0, 2, 4, 6, 8 and 10. And on the y-axis, you will have 2, 4, 6, 8, 10 and y dash will have minus 2, minus 4, minus 6, minus 8, minus 10. So now we are doing step 3, that is to draw the graph. So once you mark the x-axis, y-axis and y dash, write the scale x-axis 1 cm is 2 units, y-axis 1 cm is 2 units. Now mark the first point, x is 0, y is minus 10, so this is 0 and minus 10. So this point here is 0, comma minus 10. And the other point is 10, comma 0, so x is 10 and y is 0. This is 10, comma 0. So join these 2 points and then write on the line x minus y is equal to 10. Now the next 2 points are again 0, comma minus 10, that is here itself, and the other point is 5, comma 0. So 5 will be the middle of 4 and 6. So this is 5, comma 0. Then you join the points, just extend it further, and on this you write 2x minus y is equal to 10. Now step 4, to obtain the feasible region. So to obtain the feasible region, you should consider the inequalities. So consider x minus y less than or equal to 10. So put x equal to 0, y equal to 0. So you'll get 0 and then here you have 10. Check whether 0 is less than 10. It is less than 10. So you write true. Then take the other inequality. Consider 2x minus y less than or equal to 10. Again put x equal to 0, y equal to 0. So you will get 0 and then on the right hand side you have 10. Check whether 0 is less than 10. It is less. So again you will write true. So because both the conditions are true, you have to shade towards the origin. So these are the 2 lines and the origin is here. So take this line, the first line, x minus y equal to 10. So shade towards the origin. I have used red color. Then take the other line, that is 2x minus y equal to 10, and I have used blue color and shaded towards the origin. Now for a maximization problem, actually we have to get a closed figure. Closed figure means you have to see whether you have both the types of shading, okay, and it should actually lie in only the first quadrant, because only the first quadrant x and y will be positive. We cannot get a y value as negative or x value as negative. So if you observe, the common area, that is for both types of shading, is actually this whole area. It is actually an open figure. So for a maximization problem, whenever it is an open figure means it is not closed on all the sides. Closed figure means either it will have 3 sides or it will have 4 sides which are closed. But this one, this area, that is that common feasible region, it is not closed here at the top. Okay, so it means it is an open figure. So whenever a maximization problem has an open figure, then there is an unbounded solution. So conclusion will be the given LPP has an unbounded solution. Subdivision D, maximize z equal to 3x minus 2y subject to x plus y less than or equal to 1, 2x plus 3y greater than or equal to 4 and x comma y greater than or equal to 0. So step 1, convert inequalities to equalities. So x plus y is equal to 1, then 2x plus 3y is equal to 4. Step 2, to obtain the points of the two lines. So take the first equation, consider x plus y is equal to 1. Put x equal to 0, so you'll get y equal to 1. And put y equal to 0, so you'll get x equal to 1. So therefore 0 comma 1 and 1 comma 0 are the points of the line. Then take the next equation. Consider 2x plus 3y is equal to 4. Put x equal to 0, so which implies 3y is equal to 4, or y is equal to 4 divided by 3. You can just take maybe one place after the decimal. So 4 by 3 you will get 4 by 3 you will get 1.33, but you can just take it as 1.3. Next you put y equal to 0, so you'll get 2x is equal to 4, which implies x is equal to 4 divided by 2, which is 2. So therefore 0 comma 1 by 3, 1.3 and 2 comma 0 are the points of the line. Then step 3. So step 3 is to draw the graph. So I've drawn the graph above. So first we need a 0 comma 1, 1 comma 0, 0 comma 1.3 and 2 comma 0. So on the x-axis I have taken 1 centimeter as 0.5 units. So first 0, then 0.5, 1, 1.5, 2, 2.5. Then on the x-axis also I have taken 0.5, 1, 1.5 and 2. So mark the first point 0 comma 1, that is here, and 1 comma 0 is here. Join both the points by a straight line and then write on the line x plus y is equal to 1. Take the next point 0 comma 1.3. So this is 1.5 and this is 1. So the sixth line in between 1 and 1.5 will be 1.3. So this is 0 comma 1.3 and this point is 2 comma 0. Join these 2 points by a straight line, and on that line you write 2x plus 3y is equal to 4. Next is step 4. So step 4, to obtain the feasible region. So how do you obtain the feasible region? I have already worked out many problems now. So you should consider both the inequalities. So first take the inequality, the first one, that is x plus y less than or equal to 1. Then you have to put x equal to 0, y equal to 0. So on the left hand side you will get 0, on the right hand side you have 1. Check whether 0 is less than 1. It is less than 1. So you will write true. Then take the next inequality. So next inequality is 2x plus 3y greater than or equal to 4. Next again put x equal to 0, y equal to 0. So what will you get on the left hand side? You'll get 0. On the right hand side you have 4. Is 0 greater than 4? 0 is not greater than 4. So it is false. So when it is true, you have to shade towards the origin. When it's false, away from the origin. So for the first line, for this line, it is true. So you have to shade towards the origin. I will use blue color. And for the other line, it is false. You have to shade away from the origin. That means on top of the line. Now you'll observe that for this problem, there is no common feasible region. That means the blue color and the red color are not meeting anywhere, and you should remember that for a maximization problem you should get a closed figure. So because the shading is on opposite sides, it means that the LPP has no solution. So conclusion, the given LPP has no solution. Section E, minimize z equal to 2x plus 3y subject to x plus y greater than or equal to 350, 2x plus y less than or equal to 600, and x comma y greater than or equal to 0. So start the problem. Write step 1. Convert inequalities to equalities. So x plus y is equal to 350. 2x plus y is equal to 600. Step 2. To obtain the points of the two lines. Then step 3. So take the first equation, consider x plus y is equal to 350. Put x equal to 0. So you'll get y is equal to 350. And put y equal to 0. So you'll get x equal to 350. So 0 comma 350 and 350 comma 0 are the points of the two lines. Then take the next equation, consider 2x plus y is equal to 600. Put x equal to 0, so y is equal to 600, and put y equal to 0. So you'll get 2x is equal to 600, which implies x is equal to 600 divided by 2, which is equal to 300. So the points are 0, 600 and 300, 0. Then we move to step 3, that is to draw the graph. So I've drawn the graph above. So now on the x-axis, I have taken the values as 0, 50, 100, 150, 200, 250, 300, 350, and on the y-axis, I have taken 100, 200, 300, 400, 500, and 600. So scale x-axis 1 centimeter is equal to, it's not clear over here, so actually it is 50 units. So I have taken 1 centimeter is equal to 50 units for the x-axis, and for the y-axis I have taken 1 centimeter is equal to 100 units. So now mark the first point, that is 0, 350. This is 0 and 350 is the exact middle of 300 and 400, that is here. And then you mark 350, 0. So on the x-axis, here you have 350, so it's 350, 0. So then join the points 0, 350 and 350, 0 by a straight line, and on that line you write x plus y is equal to 350. Then take the next 2 points 0, 600, so that is here, and 300, 0 is here. Join these 2 points by a straight line, and on that line you write 2x plus y is equal to 600. Then you move on to step 4 to obtain the feasible region. So to obtain the feasible region, you should take the inequalities. So consider the first inequality, x plus y greater than or equal to 350. Put x equal to 0, y equal to 0. So you'll get 0, and then here you have 350. Check whether 0 is greater than 350. It is not greater. So you will write false. Then take the other inequality, that is 2x plus y is less or equal to 600. So put x equal to 0, y equal to 0. So you have 0 and then 600. Check whether 0 is less than 600. It is less than 600. So you'll write true. So for the first equation it is false, and the second equation the condition is true. So this is the first equation, that is x plus y equal to 350. So it is false. So you have to shade away from the origin. So I have used the blue color, that is I have shaded on top of the line. Then the other equation is 2x plus y equal to 600, that is this line. For this it is true, so I have shaded towards the origin, that is I have used a red color line. Now what you have to do is, it is a minimization problem. For a minimization problem, you can have an open figure or a closed figure and still you will have the solution. So now find out where the two types of shading are meeting. So if you observe carefully, this is the area where the two types of shading are meeting. So mark this as A, 0, 600. This as B, that is 0, 350, and this point here is C. So from this point you draw a perpendicular to the x-axis. So it will touch the x-axis at 250, and from this point draw a line parallel to the x-axis. It is touching the y-axis at 100. So C, the points are 250, 100. So step 5 is you have to write the corner points of the common feasible region. So now let us write the corner points. So step 5, the corner points. So the corner points are A 0, 600. Then you have B 0, 350. C is 250, 100. Then step 6 is to evaluate Z at the corner points. So you consider minimize Z equal to 2x plus 3y. So ZA is equal to 2 into 0 plus 3 into 600 is 1800. Then ZB is 2 into 0 plus 3 into 350, which is 1050. And ZC is 2 into 250 plus 3 into 100. So this is 500 plus 500 plus 300. It is equal to 800. Now because it is a minimization problem, find out the least value here. So the least value is 800. So you can write the conclusion. The given LPP has an optimal solution at C 250, 100 and minimum Z is equal to 800. Thank you all for watching Statistics Made Simple, and I do hope that this video where I've solved problems on linear programming problem is going to help you to score the 5 marks, which is a sure question, that is a 35th question in the second PUC statistics question paper.